Awesome, thank you. So my name is Mark, and I'm here to show off the IQEngine open source project. I'll talk about where it's headed in the future as well. Also here we have Roman, who's involved in IQEngine as well as SIGMF. And this talk is aimed primarily at two groups. One is folks who are newish to SDR and RF signal processing, students, hobbyists, anyone who wants to learn more about all this software that you're seeing. And then second is folks who run or maintain an open source project that involves RF signal processing in some way. And hopefully, even if you're not in those groups, you'll still find some interest here. So IQEngine, currently, it's a web app that is all about RF recordings. It lets you preview recordings, manage them, analyze them, some light processing, and then most importantly is sharing, and all in your browser, so entirely web-based. And I'll show a quick little demo of what the current tool looks like. So IQEngine it's available at IQEngine.org. The project runs a public instance of the tool. But in this case, I've got one running locally because I wasn't sure about Wi-Fi. So the main screen here is essentially a list of these RF recordings. They're all stored in the SIGMF format, if you're familiar with SIGMF. We have some good ones from Jean-Michel and Aang23, a lot of folks who are here today. You can also open a recording that's local to your machine, and then all the processing's done client-side. So like I could open a local directory full of recordings. Here, recordings, and it'll list out them all, generate the thumbnails. So actually, it's the same directory that I had served from the server. You can also open just one local file pair. So sort of, anyway, so back to the list here. If you click on one of them, you're brought to a spectrogram style interface where it loads the samples that you're looking at any given time, so that way you can have enormous files. And then the mini-map on the right represents the entire recording. So you can jump to any part of it, and the little gray area is the part you're looking at. We have time, frequency, and IQ, like you'd expect. Oh, that's FM. And then some other features here are, so there's time and frequency cursors if you want to measure stuff, adjustable, dynamic range for the color, windowing, FFT size. You can add in FIR filter taps, and all of that is run client-side. The FFTs are done client-side, the FIR filter is. But the one part that's not client-side is our plugin system. So if you select a portion of the recording that you want to send to the plugin server, you can select it there, and then let me zoom in here. Choose a plugin. So this was an FM recording, so I'm going to run an FM receiver that's implemented in GNU Radio, and it sends the samples to the server that runs GNU Radio, and then in this case it's actually returning a WAV file with the audio of that signal. But there's other types of outputs, like you could run a block or a plugin that gives you IQ as the output. So if I do a low-pass filter, it's just going to output IQ. Let me give it a proper cutoff frequency there. And then currently we're just displaying the IQ in a pop-up. But in the future, we're trying to figure out the best way to replace kind of the signal that's already on the screen with this new one so that you can chain plugins together. So that's sort of the gist of the tool. Now back to the slides here. So everything's, IQEngine's built on top of SIGMF in many ways. If you're not familiar, SIGMF, it's an open standard for saving your RF recordings to a file. It's as simple as it gets. You have a binary IQ file, which is sort of the native way to store a recording. And then a JSON file, and the SIGMF specifications mainly tell you how to write that JSON file. So there's stuff like how you specify sample rate, center frequency, data type, and then I'll show you annotations in a second here. And by using SIGMF, you have software interoperability, and then you can also avoid data bit rot, where like in 5 years you forget what sample rate stuff was taken at. If you want to learn more about SIGMF, there's a link at the top of IQEngine.org, and it also links out to the SIGMF GitHub page. So SIGMF, the standard is managed by GNU Radio. It's kind of a sub-project, sort of. Now, as far as the IQEngine code itself, it's web-based. Front end uses React, Tailwind. Some big dependencies that we get a lot of use out of are CodeMirror for all of the code editing. Pyodide lets us run Python in the browser. I didn't demo that, but there's some videos online about how that gets used. And then Plotly for those time, frequency, and IQ plots. WebAssembly for FFTs. And then for our documentation, we use the MDX system, which lets us write it in Markdown and then have it rendered as part of this page here. So this was written in Markdown, and then it lets us render it in as React components. Kind of nice. Now, so that was kind of the introduction, but I wanted to start off where I left at GNU Radio Conference last year. So what have we done since then? Well, now it's possible to run a local instance of IQEngine. Like if you want to run it within an organization or whatever to share things privately, you can run an instance and you can put the recordings on the same server. So easy enough. Or something that's mounted to the file system. As long as Python open can see it, then it can serve the recording. And the other option is to use cloud storage, which is what we do for IQEngine.org. And as far as how to do that, so the general idea is you pick a directory on your server, and then you can run IQEngine with the Docker images. So if you go to the install with Docker page, all you have to do is change the directory that's mounted into the container. So pretty much this part here of the command. And then the rest of this command will pull the latest IQEngine Docker image, and it'll run it. And you should be able to see your recordings. They'll look like this because they'll be local to the back end. Versus IQEngine.org, which has a few different data sources that pop up here. And that's fairly new. If you end up using this and notice some quality of life issues, definitely reach out on Discord or GitHub. So next up, I'm going to dive into the plugin system that you saw me run with the FM receiver. So the idea is any RF signal processing that you want to run on a back-end server, but triggered from the browser. So what we have within our project is this REST-based API, and it allows for someone to write the plugin server in any language they want. We have an example in Python, and then Loic wrote one for Rust. The Python one can run GNU Radio flow graphs. It just pretty much runs the Python flow graph, and then uses ZMQ to get samples in and out of it. But in the future, there'll be more languages, and by using this REST API, it doesn't matter. It could be really, you can deploy it and implement it however you want to, as long as it supports this interface. I'm going to show a little demo later running SatDump, which is kind of an example of a whole separate project, not a GNU Radio flow graph or anything, but a piece of open source software that you can trigger from IQEngine. And then Aang will be presenting more about SatDump in like an hour or so. So as far as how the plugins look, the Python-based ones, we try to make it as easy as possible to create a new one. This isn't the actual REST API. This is just how you would make a new Python plugin, and then you would use an existing server code that we already have. So you can see you have to specify your custom parameters, and then there's a run function where you're given the samples, and you have to return several different data types. As far as GNU Radio, you specify the flow graph, but the only catch is you have to substitute your file source and GUIs with the ZMQ source and ZMQ sync. That's how we get samples in and out. Not the most performant thing, but it gets the job done. So you can see these first couple blocks are the ZMQ ones, and then the rest represents the flow graph. So we have a Python flow graph that implements an FM receiver in this case, and that was the plugin that I ran earlier. So this is, the kind of the motivation here is if you are an author of an out-of-tree module for GNU Radio, you probably already shared the code somewhere like GitHub and created some examples, some example flow graphs. But the next step would be making it more accessible and easy for folks to find and play with. And I think this could be an option there by exposing it as a plugin. Now, let me go back to the plugins. So I'll go ahead and run the satdump one. So I've got a recording of NOAA APT right here, contributed by Ing. So I can click that. I can browse around the signal. I'll notice, oh, it's actually offset, but I believe this is the APT signal. You could jump to different parts of the file there. And then as far as running it through satdump, I want to run the entire file because it needs a decent amount of samples. So I'm going to select the whole file. And then under plugins, we've got the fresh new satdump plugin already preloaded with the pipeline for APT. But you can put whatever pipeline you want. And so right now it ran satdump under the hood. So here's the one of the images that comes out. I think IQEngine still has some work to do as far as if you have a bunch of different outputs, how do you present them all to the user? There's a lot of web design that can go on there. And yeah, so either it pops open something or it saves a file. And it supports all the different MIME types if you're familiar with web. It sort of just uses MIME type, and then we added some custom MIME types for IQ, like the different data types for SIGMF. As far as other plugins, I think, yeah, pretty much. Oh, we have a detector as well. So let me go to a recording that I give my students when we study signal detection and classification. So this is kind of like a toy example meant for testing a detector where you have a few different signals here. And IQEngine is not about implementing RFML. It's about like sharing it and making it more accessible. So we made a very simple detector just to have an example. It's written in Python. You're welcome to check it out in the source. It's called Simple Detector. We also have Marco's detector. He was someone else who was working on it. Simple Detector is pretty quick for that number of samples, and it did a decent job. There's one extra little detected emission there. Now, the results are in the form of SIGMF annotations, which are bounding boxes in time and frequency, and that's how the results are shared from the plugin. So if you wanted to download the raw metadata file, the SIGMF file, you can go to the bottom here, and here are the annotations that the plugin created. So we sort of copied the SIGMF format for the return data type. And if you wanted to perform classification, you would simply fill out the label, and they would show up. Within IQEngine, you can also edit the annotations and edit the labels. So if you wanted to manually tweak stuff, like you were making an RFML data set, sort of like a golden meta file, you could do that here. Or what I find most useful is simply to have a quick glance at how well something worked, right? It's not, if you had tons of files to run through, you wouldn't want to do all this clicking. You would just make a script. And you could certainly run the plugins from a Python script. It would just need to call the REST API. Back to the slides. All right, so I want to take just a really quick tangent to mention, remind people about what GNU Radio provides, and then how it relates to this plan that the project has. So GNU Radio, it's a way to implement your RF DSP in C++ or Python. It gives us a standard framework for doing that implementation. It's easy to get annoyed at the boilerplate and how to install everything. But in the end, if you use that framework, it means that other people who are familiar with GNU Radio can then install your out-of-tree module They sort of know like the standard usage of your blocks, where to look for the example flow graphs, how to connect your application with their SDR sitting on their desk. And that's an enormous value. That's like, in my opinion, one of the main values of GNU Radio. Now, and then the GUIs are nice as well. It's not always easy to program GUIs. So if you're curious about learning about different out-of-tree modules, cgran.org is where we point people. And I mention this because cgran represents a centralized location for GNU Radio applications and libraries, what we call out-of-tree modules. But kind of zooming out one more layer, going beyond just GNU Radio is what I'm going to talk about here in a sec. So let's say that you're a developer of open source software that involves RF processing in some way, like you wrote SatDump and you're doing satellite signal processing. You build something, you want to share it, you want to keep it easy to demonstrate and show off to people, easy to use, right? Those are sort of the main steps you might take. Now, on the other side of things, you have users out there, whoever they are, individuals, students, organizations, who first they need to discover that this software exists. That's like the very first step. And then how do you install it? How do you run it properly? How can I evaluate how well it's working and use it with my SDR or my recordings, right? So kind of a duality here. On the developer side, you might post your code to GitHub. You might share it as part of a FOSDEM talk, right? Those are sort of, that's kind of like the current method that we use. On the user side of things, you might Google the topic you're interested in, like specific satellite, Wi-Fi, whatever. You'll probably come across what's out there, but it's not the best way to do it, right? Just by Googling. So installation can be an enormous barrier. So I teach, when I teach CS students who, well, it depends who you are, but like some students and some folks are better at getting this software installed than others. Obviously, having a lot of Linux experience helps. Folks who are new to Linux but want to dive into signal processing, they can struggle here and there. So it can definitely be a barrier. Now, how do you actually run it? If it's a GNU Radio flow graph, you probably know how, but not everything's easy to use. There's RF libraries out there that are not clear how exactly do you use it, but it's powerful. And then lastly, evaluating the software. Maybe you're going to use it as a dependency or use it as part of a project. So this idea to sort of evolve IQEngine, so instead of just being a way to share and evaluate RF recordings, it can also be used for just RF open source software in general. Sort of like a central hub, community-driven for devs to share stuff, for users to find and discover software. And then by exposing the software as a plugin, they can try it out on recordings that are already on the site or their own. And then one side benefit is universities and anyone else who wants to show off their expertise and creates open source software, they can use this central hub as a way to do that. Now, this is all in the browser primarily for accessibility's sake. Like, it's not the most performant way to do something like this, but it's extremely convenient. Really, it removes a lot of barriers. So users would be able to play around with a certain function using a variety of recordings. And it's more than just using recordings. They can try, in the future, maybe there's a way to lower the SNR, like add noise, and see if it still works, or whatnot. Add a frequency shift, see if the RF function still works. And then on the author side of things, all you really would need to do is add this REST-based interface, or at least make it easy to call with CLI and then retrieve the results. So like SatDump, I'm not using a REST interface. I'm just running the CLI in a way that's, Anyway, now one design decision that was made was to allow multiple plugin servers to connect to a single IQEngine instance, like at IQEngine.org. That way, like a university could run their own plugin server, have total control over it, but they could share their expertise, everything they want to show off. And this is really just a concept. So right now, I showed you how IQEngine lets you preview RF recordings and RF data sets. Well, I think in the future, with these building blocks that I showed through the plugin system and this REST interface that we're designing, you could have a tool that would be used for previewing what I'm calling functions, apps, software, really anything that involves RF signal processing. Now, there are limitations, so a lot of RF apps can't simply be like run on a recording. So SRS RAN, excellent LTE and 5G radio stack. Because of LTE and 5G's like strict latency requirements, you can't easily like just play it back, or it's not straightforward. Simply running it on a recording. You sort of want to simulate that closed loop system. So not all RF functions and apps are going to be shareable this way, but I think a vast majority of them are. Definitely GNU Radio apps and those kind of processing applications. The other thing that you wouldn't show off is like an SDR interface, like a GUI, right? That wouldn't make any sense. So now, if you're interested in contributing, it's a community-led project. So we can always use more web devs. It turns out that the kind of folks in these RF circles tend to know C++, Python, but less so on the web side. And I know I've had to learn a lot of web development to to get this project moving more. So even if you're not a web developer, there's plenty of other ways to contribute. We're always looking for more interesting RF recordings to share. If you have an entire data set, we can add like a whole category here on the left. So we have Daniel Estevez's awesome satellite recordings as an example, where we can link off to your website. And so yeah, if you want to get involved in any way, there's a Discord link at the top of IQEngine.org. We have a little community that's slowly building. And with that, I will take questions. Yep.
I've seen some other products that do this, combine geolocation data.
So yeah, the question was related to geolocation data, like running it as a plugin, I assume.
And then displaying it, so we have the weather maps, which all look like the national boundaries underneath the map.
Yeah, while I explain that, so there actually is already a maps-based interface for, anyway, when we designed the API I mentioned, we made sure to allow multiple channels of RF. So those channels could be time-synchronized recordings from different sensors. That way, at least you could run it from the back-end perspective. And then, yeah, I guess we would need to add a maps interface to the spectrogram page to make that fully happen. But great suggestion. Yep.
Do you have a public storage that I can just use to upload capture to?
Well, so GNU Radio has some Azure credit that they got, and that's what we've been using for a lot of these recordings. So, and we can use that for other folks' recordings if they want to share it publicly. Yeah, you can reach out and we can transfer it over, and it would fall.
Does it still require credentials and Azure login and everything?
No. Like I could like upload it for you to the GNU Radio has a blob storage account, so I could give you a SAS token for you to upload it yourself, or I could upload it for you. Yep, I think there was one more.
It seems like it would be a useful feature for people to be able to just submit something through the website rather than just having to contact you. And
Yes, there is something that's a work in progress, but I guess I'll share it. So there's an upload page.
That's what I meant, yes.
Oh yeah. So IQEngine.org/upload should allow you to upload a recording. Wi-Fi is not great, but yeah. That would be the first place to go. I think we're out of time. Any last question? Yep.
so how well does it actually handle very, very big files?
So, it was designed to deal with terabyte files from the start, which is why we have that mini-map. And when you open the spectrogram page, it's only loading what you're looking at any given time. So it's sending the IQ samples to your client, to the browser. the browser's doing the FFTs. So it's sending maybe a few million samples to get a spectrogram like this, but if it's a many terabyte recording, you'll just have a smaller like gray window here because it'll represent a smaller part of the whole recording. Yeah, I mean, you have to store the recording, but it's not all, we have no part of the code that sends the entire recording to either the client or the backend, because we know it's not going to fly for huge stuff. All right. Oh, yeah.
Yeah, the JSON metadata does also store things where things at the front end, like the low noise amplifier gain, bandwidth.
Oh, yeah. Actually, SIGMF has a lot of, there's even an extension for more details about the hardware involved. Definitely check out SIGMF, the specs. So if you want a 5-minute introduction to SIGMF, that's what we have here on IQEngine. But I would, go ahead and go to the specs and dive in, and you'll know a lot of the parameters that you mentioned. Yep. All right. Thank you very much.
Mark?